All right, guys, lecture 7.1, oblique triangles and the law of sinus. So the law of sinus relates the angle and side lengths for any triangle. The law of sinus comes from subdividing a triangle into two right triangles using an altitude and then working out multiple equal expressions for the altitude. So I'm going to write on the side some we call knowledge about solving right triangle, and then I will get back to you. All right, guys, so I just wrote very quickly, and I would like you to take these notes also, that first of all, I recall the knowledge about solving right triangle, Pythagorean theorem, the fact that the angle A plus the angle B equal 90 degrees, and in a right triangle, the expression of the sinus of the angle A, the cosinus, and the tangent of the angle A. What if we don't have a right triangle? Well, the sinus of the angle A being equal to A over C is no longer applied because C is not equal to 90 degrees and the length C is not the hypotenuse. So what do we want to do if we don't have a right triangle? Well, basically we need to, like you can see, make sure that we can draw an altitude, because when you draw an altitude, you end up to create two right triangle. If I name with the letter right here, I'm going to letter D. Well, you can see the right triangle ADC, but also BDC. Okay. When you work this out, finally at the end of the day, you are able to get to the point where you have your your law of sinus. So I'll let you write all of this stuff. You can always pause to write all of this note. Take your time, and everything will be all right, okay? So I said everything what I want to say. So let's jump to the practice number 1, and we try to solve this triangle. So if I want to solve it, what I want to do is very simple. So I know with my love sign that sinus of the angle A divided by A equals sinus of the angle B divided by B. I know the value of the sinus of the angle A, 98.1, divided by the length of A, which is 5.7, and it's equal to the sinus of B divided by 4.2, as 4.20 is the length of B. If I call that A, B, C, with A equal, B equal, and C equal question mark. Well, I'm able to express sinus B equal to 4.2 divided by 5.7 multiplied by sinus 98.1. And therefore, B equal the sinus to the negative 1 of 4.2 divided 5.7 multiplied by the sinus of 98.1. You are going to find a B. Don't forget to have your calculator in mode degree, equal to 46.8437 degrees. And you are going to decide to write B equal 46.8 degrees. Okay? Still true that A plus, it is still true that A plus B plus C equal 180 degrees. And so it's pretty easy to say that C equal 180 minus 98.1 minus 46.8, and I end up to have an angle C equal to 35.1 degree. We can't use the Pythagorean theorem to find the side C because we don't have a right triangle. Okay, so to find C, lowercase c, we cannot use the Pythagorean theorem. Okay? We can't use that because we don't have a right triangle. a right triangle. So what do? Well, we are going to use the law of sine. So the law of sine is saying that sinus of the angle C divided by C equals sinus of the angle A divided by the length A. So if I'm looking for find C, I'm going to multiply by C top and bottom. By doing so, now C is on the top of my fraction on the right side. I'm going to multiply by A top and bottom to get, I'm going to put the A in the front. I'm going to multiply by A top and bottom to get rid of the A on the left side, but I'm going to also divide by sinus A because I'm looking for having C standing by itself, so I need to divide by sinus A. And so now I can easily rewrite that C is equal to A sinus of the angle C divided by sinus of the angle A. Why did I put A like this? I'm supposed to put A like that. My apology. And so I end up by substituting the value that C is equal to 3.31. Okay? So that was the practice number 1. Let's try to solve with the practice number 2. So first of all, let's name my triangle A, I'm going to call that B, and I'm going to call that C. Okay? Therefore, that is C, that is A, and that is B. I know the expression of B. I know the angle, 15.1 right here. I know the big angle, I know the angle C, 100. So if I want to know the angle B, pretty easy. B is going to be equal to 180 minus I think there is a tiny mistake. So what I'm going to do is B is not equal to 22.7 centimeter. The angle right here is 22.7 degree when the distance is supposed to be 15.1 centimeter. Therefore, if I want to calculate my angle B, it's going to be 180 minus 101.5 minus the 22. So right here, this is not the angle. The angle is 22.7 degree, 22.7 degree. And we end up to have B equal to 55.8 degree. Now we have the angle B. I can apply my law of sine A. Sinus A over A equals sinus of the angle B over B. That is exactly the same thing that if you have A over sinus A equal B over sinus B. So now you can, by substituting the value, end up to have A equal 15.7 multiplied by the sinus of 22.7 divided by the sinus of 55.8. And you end up to have a 7.05 centimeter. Okay? Okay. Now, if you're looking for the value of C, now you find A. What you can also do is use your law of sinus and write sinus C over C equal sinus B over B. That could be also C over sinus C equal B over sinus B. All right, I'll let you do the calculation by yourself. And you should find C equals 17.9 centimeter. All right, practice problem number 3. So what do we have? Suppose you measure the angle elevation to the top of a building to be 48.2 degrees, then you step back 52.7 inch and measure the new angle of elevation, 37.9 degrees. If you're measuring your instrument is 6, actually it's not inch, it's foot, 6 foot above the ground, or 6 inch above the ground, or 6 inch, or 6 foot, it looks like 6 foot. above the ground, what is the height of the building? So first of all, you must represent your problem properly. So what I'm going to do is I'm going to do the drawing, and then I get back to you. All right, guys, so now you have the problem in front of you. You have your building, 48 degree, and then you go back 52.7 feet, and you have another angle where you're looking at your building, 37.9 degree. Your size, 6 foot. I forgot to put that right here, 6 foot. So the question is, if your measuring instrument is 6 foot above the ground, what is the height of the building? Well, we need C, okay, to solve the right triangle for H, right? So the first thing I want to do is we need C to solve the right triangle, solve the right triangle for the altitude H, because if I know the altitude lowercase h, I will know the altitude of my building, which is H, what I found, plus 6 foot. So what do we have? First of all, B is supplementary. B is supplementary to the 48.2 degree angle of elevation. So to find B, pretty easy. B is going to be equal to 180 minus 48.2 degree. And to find an angle B equal 131.8 degree. Now, A, the angle A, is going to be equal to 180 minus 37.9 minus 131.8. And so I find angle A equal to 10.3 degree. So I got B equal 131.8 degree. I got A equal 10.3 degree. All right. Let's continue on the side right here. Okay, so I'm going to continue up here. Using my love sign, C over sinus of the angle C equal A over sinus of the angle A. That means that C is equal to A times sinus of the angle C divided by the sinus of the angle A. I substitute the values. C equals 52.7 multiplied by the sinus of 37.9 over the sinus of the angle A, but I know now equal to 10.3 degree. And I find a value of the length of the triangle, C equal 181 feet. Knowing C now, I can express the H, because I have a right triangle, and I know that the sinus of 48.2 degree is equal to H over 181 feet. And so therefore H is equal to 181 multiplied by sinus of 48.2 degree. Don't forget to have your calculator in mode degree. And so H is going to be equal to 135 feet. Therefore, the height of my building, capital H, is equal to H plus 6 foot. It's going to be equal to 135 plus 6, which is 141 feet. Okay? Now, in terms of area, you have all the formula. It's just about applying the formula. If you know the value of lowercase b, lowercase c, and the angle A, you will know the area of this triangle. So you have to remember it's just applying these rules, these definitions, okay, this formula. I think I'm done right here, so I will see you in class and talk to you later.